Hi, good evening.
Hello.
Hello.
Good evening.
Hi. I'm on.
Hi.
Hello. And also hello, Martin's cat.
Yeah, she's back.
Wait, she's back. Was she ever gone?
No, but I mean from the stream. I think it's been a while.
That's true. I wish I was a cat sometimes, They can just enjoy life, get food every day.
Yeah,
Yeah.
I think there's a musical about that.
Next time
Actually, it was a documentary.
Yeah.
Two more missing.
Hello.
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 Okay, I think we are complete. Check quickly. Yes.
Is it just me or GitHub is terribly slow today?
Internet or what?
Well, the GitHub itself, like the other stuff it works, but the GitHub just takes forever to load.
Let me check. No, it's super fast.
Not noticed. No.
It's a local CDN, right? Okay, let me quickly share.
Is this a primary meeting?
Yes.
Yes, it is. But I mean, we haven't made anything special for the primaries in any case for the last couple of times. But we can do a review. Okay, let's get started. So let me remind you that by being here, we all agree to the GraphQL spec membership agreement, the participation guideline, the contribution guide, and the code of conduct of the GraphQL Foundation. Also, these meetings are recorded. If you don't agree with that, please disconnect now.
I.
We are also using LLMs to do summaries of these meetings. Let's start with a quick round of introduction. My name is Michael, and I'm the host. Tom, you're next.
Yeah, I'm Tom Ule from GraphBase.
Hey, I'm Derek from Apollo.
Pascal from Chili Cream.
Camille from the Guild.
Martin from Apollo.
The Chin from Apollo.
Awesome. So the last couple of meetings, we were going through issues that are still open on the repository to kind of get the scope of the specification for the first version, and also going through the field selection map syntax that we have that define requirements. That's the last two meetings, I would say, and to really see where we need changes maybe, or where it works out well. And I think the main contention that we have still that we are working through is on requirements, the choice that we have, and what the choice even means. Did I summarize that correctly? So let me give you a quick example to go right in here. Go into the GraphQL mode. So when we talk about the field selection map, it's actually used in two places. One is for lookups, when we have, for instance, product resolver here that resolves the product by ID. And this guy here is called a lookup. And if this is not clear what this argument actually does or what it is, then we have here an is directive that defines what it is, right? In this case, we don't need it, but if this would be called product ID, for instance, then this would be needed because we cannot infer that from the return type of this field. So where it gets more interesting is if that is not just a simple lookup here, which just has this single ID, but is something that we call a one-off field, right? Where we have, for instance, a by input. And then in the is, we have a choice of things. Like this could be an ID or an SKU. Quickly put this in. Awesome. And then we have this as a one-off. Okay, in this case, the lookup here can resolve two kinds of keys, the ID key and the SKU. And why this is so clear in this instance is that either when we exit a schema, we either have an ID or an SKU, then we can use this lookup to transition to a subgraph, right? Where this gets a lot more interesting, the discussion, is actually when we talk about requirements. And that is where the main discussion points are. Let's say this has an expected delivery. And here we require some data, for instance. Oh, that's the wrong thing. Here. And we have here a requirement for a dimension input. Then we have, as of now, defined that you can also have here one-off input or a choice. And the choice here is, I think we are not clear enough also what we mean with choice. Is choice only in the case of one-off? Is it also in other cases? And let me give you a quick example here. Let's say product, for instance. It doesn't matter. Let's say just the thing here, dimension, could return a movie dimension. Dimension. Da. Sorry. And then we want from that, I don't know, the weight. And otherwise, if it's whatever else.
It's the emotional weight of the movie, right?
Yeah. That's very good.
Yeah, it's also a bit worrying that this influences the package delivery time. I wasn't
Is it?
expecting
Yeah.
my delivery driver to actually watch the movie. Where they are always late, you know.
Or the book dimension. And in
Yeah.
this case, we have the actual
Reading
weight.
time, I guess. I don't know.
Let me just complete this here. Okay. So in this case, we have here a choice depending on the type. And this would translate to a selection set. Maybe I also write that down. So the selection set that we would translate this to is very, very simple to understand. And I think there is not the convention we have here. The first one where I say if it's a movie dimension, then we want this. Sorry for the horrible typing here.
Mistake. That's when you start, with graph.
Yeah.
The weight. But if we like up here, it's not that we discard data, right? We have certain data. So we know at this exit point, either ID or SKU are available. So we can choose this. But here it's like, okay, we do the selection and then we discard one of the object constructions that we have and would either create an object with a field emotional weight or weight, just with the weight, right? And that is different to, for instance, how federation works at the moment. And also like it's not really clear when we discard it, right? This
Yeah.
maybe
And
seems
it's like they're not necessarily exclusive, right? Like there's no requirement for movie dimension and book dimension to be mutually exclusive types. Like you can have multiple type conditions with like various abstract types in there. So I think it becomes really hard to know before you've actually like interpreted the selection set what the result is. Like it's not something like the choice doesn't necessarily add anything here because in my mind the semantics are still you first execute the selection set that gives you a result map. So you sort of know which fields are in there. So if it's not a movie dimension, the emotional weight field won't be in there. Like it won't be null, but it simply won't be in there. And then it depends on what you're trying to map to. So if dimension input has both emotional weight and weight, and it's not a one-off, that's fine. Like you can map to those different fields. It's only when it's a one-off that the additional semantics come in. And I think it's very similar to like I think you can compare it directly to including like an input object literal there. Like if you were to write an input object literal here and you included both emotional weight and dimension input was a one-off, that wouldn't work. But that's because of the one-off semantics, and that has nothing to do with the mapping language semantics.
yeah. Like if we had this guy here. And this would be the dimension input, right?
Yeah.
Then the one of semantics is that I cannot have both filled. And I can even not have like even this would be invalid, right?
Yeah, but you get 1 second. 1 second. You would get no, because it's undefined. It's not null. Fair enough.
Yeah.
Yeah. Okay, that's fine.
So even this, just to get this right, even this would be invalid.
Yeah.
Right? Because one of demands that we either we need this or the other way around.
Yeah. And I think my worry with the choice operator here is that it's duplicating those semantics. Like we already have specified semantics from converting from a literal to an input object, including one of, and now we're introducing our own evaluation rules based on choice, potentially duplicating that. And it seems simple in sort of simple cases, but it can get pretty complicated when you think about overlapping conditions.
I think yeah, you know, I've sent this message to the channel, and when you think about the choice as evaluated left, so first of all, default evaluation is what you suggested last time. If you don't have a choice, an object will be evaluated with the default. So when you have a type condition, movie dimension like here, and it's
Mhm.
not movie dimension in JavaScript, this would essentially lead to an undefined, which is very different from null.
Yeah.
If you assign an undefined value to an input, this input is undefined, so it's not set. So this
But that's what you want for a one-off.
yeah, exactly. So this
Yeah.
is exactly the default evaluation rule. If you do not have a choice operator, would be that when there is nothing, when you select nothing, you can also set nothing. If you select null, it will be null. If you select the value, it will be set to this value. I think that one is pretty clear. The type conditions that we could add with choice, though, are a bit different, because let's think about the choice operator as just evaluated from left to right. And the last one could be considered as the fallback. So if nothing worked, we just use the default evaluation rules. And you have to have a closed choice group. It must be closed. There's no way, otherwise it's a composition error. So if you have this case where you have multiple choice, the last choice that you have here must match either emotional weight or weight, because in this case, it could still be that you have a runtime exception. So with
But the complication here is that the choice is not between those two fields. It's between two objects, literals, basically, object constructions. So they could have additional fields in there, and it isn't clear what the choice operator would do in that case.
well,
Instead, what we discussed last time was a double question mark operator, like an actual fallback operator, and I think that would be something you could use on individual fields. And it could be nested, and it has clear semantics. It doesn't affect, like choice suggests that there's some kind of union or some kind of exhaustive, or at least like mutually exclusive option.
But I would like, why not?
Yeah.
Right? Because the question mark with the fallbacks, right? That can just be not all the cases, obviously, because it's a different operator. But the default case where you actually want to assign default values could just be the last condition of a choice. Like dimension is not a movie, dimension is not a book. So what's the third choice? The third choice is a default value somewhere.
No, but what I'm saying is I think the double question mark operator is a sort of fairly well-defined binary operator. Like we know what the semantics are, and it's local. Like it's just saying like this value, if it's undefined or null, then like use the right-hand side. The choice operator, the way we have been thinking about it, and also sort of by analogy with union types, is like it has additional semantics. It really talks about sort of mutually exclusive, potentially exhaustive options. And it's really hard to define semantics for that. because it's not usually a choice between two fields. Like you can put the choice operator anywhere, and there can be complicated objects with overlapping type conditions in each of those two options.
Yeah, but then you would just
But
it's not evaluated.
I have like, just by the way, this is what Martin is talking about, the
Yeah.
question marks.
I think this would be illegal, by the way, because
Yeah.
you need to specify an alias here. There has to be a
Yes,
single
but-
field name that it matches to.
Yes,
But that doesn't work in the one.
but how do we do it in the union? Because like in
In the one-off case, you don't need the double question mark. Yeah.
yeah, because we are canceling out. Yeah.
So it's only when you want to like do something else besides just dropping it. Like if you want a fallback value or maybe a fallback alternative field, that's where you would use the double question mark.
Would this raises another question, right? Are we aware of one-off? That something is one-off?
I don't think so. I mean, at least that's what I'm trying to avoid, to sort of special case evaluation rules based on what you're mapping to. Like, I think we need clear evaluation rules that result in basically a result map, right? Or like a result value. And then whether that maps to a particular argument type, I mean, that uses the normal GraphQL like argument assignment semantics.
Yeah, why I raised the question is because like we could have proper composition errors for even in this case. We could raise proper composition errors the moment you do something like that, right? So
you mean in this case because it's an integer and a string?
No, it doesn't matter. Also
Nope.
this, right? If we are aware of, okay, this can never lead, or this at least in one case would lead, or depending on, right? It would, no, it would, in this case, it would lead in all cases to an invalid input.
Yeah.
Like why I kind of like that for the requires case, but I dislike it for the lookup case. And this really has to do with the different semantics, because this describes basically the to the query planner what needs to be delivered in each case as an exit point.
You know, I don't understand the complexity of choice operator. I really don't, because for me it's just you start evaluating from the left, and if it doesn't match, you try the next.
No, but what does not match mean? I think that's the question here. Like,
I'm
for
mentioning
instance, like here you have like just emotional weight, but let's say you add another field
Yeah, so
in there, and you have some other type condition.
can you remove the pipe quickly? And
What happens when only one of those fields is included, for instance? Like there's no.
What do you want to do?
copy line 12 so that we have the original one, and then remove the pipe on line 30 or whatever. Yeah, just remove the pipe.
Let me because it's maybe difficult to.
So make
This-
one object out of it.
Yeah.
You mean this when you have colliding type conditions, right?
Yeah, or just multiple fields. Like how do you decide whether the left-hand side of the choice operator matches if it's a complex potentially nested object? Like what does it mean for it to match?
Yeah, so now you would have both, and you have the colliding type. So for me, this choice is not valid, because this would have to have a fallback at the end where you set either one of them, because you cannot have a one-off without an input.
Yeah, but it comes really down to one-off, right?
Well,
Because
it
like
doesn't matter. You can have the same thing about other things, right?
no, but look at this, Pascal. Let me put that up here. If this is not a one-off, this is an all cases valid because these are nullable.
Yeah.
And if I send an empty object, it's perfectly valid.
Yeah, but what you can do with the choice operator is you can say when it is movie dimension, then weight is 5. When it is book dimension, then weight is 7. Like,
How do you mean?
well, you just assign a scalar value to the second field, and then you pipe it. And if not with the question mark.
Yeah, I get what you mean. So we have a pipe here.
And you could add any arbitrary logic there.
You
But,
mean
what still isn't clear to me is what the choice operator actually means here, because you seem to be defining the semantics based on single fields, like saying if emotional weight is not there. But it's a whole object you're constructing there. Like it's not necessarily one field. So what does it mean?
Well, it's when for me, so that's maybe where I misalign completely. So correct me, like just so that we talk about the same thing. If dimension is movie dimension, this choice works. If it's not movie dimension and it is book dimension, then this choice works. If it's
But yeah, but you can mix type conditions even within a single object. So if within the dimension, movie dimension, emotional weight, like I never know how to do this. How do I write on this? Did I just do this? No.
there is in the
Oh.
left corner.
Yeah.
Left bottom corner.
So if you add an additional field here.
Yes. Can you do it quickly? With a different type condition.
Yeah.
Like this?
No.
With
Keep the original one.
Okay.
Just copy the dimension thing and put in another type condition.
Okay.
Yeah, or it can be any type of field, right? Like you're constructing an object, a potentially like nested object with like overlapping type conditions. Like there isn't a single choice there.
Yeah. So
that's my point.
Let's say the dimension here would be the field dimension would be assignable to movie dimension, but it wouldn't be assignable to bar. So you start evaluating, right? And then you evaluate and you say, okay, it's dimension. Okay, so this one is good. This one isn't good. So this choice is not good.
But those are very arbitrary semantics, especially if you start nesting things. Like it isn't really clear what this is doing.
But why? Why is it arbitrary? Because you essentially specify what type dimension needs to be. And if it's not this dimension, if it's not this type, then the whole choice is invalidated.
But you're only specifying that for like one of the fields, and potentially like there could be a nested subselection in there. There could be other type conditions that like contribute to the same subselection even. So it's really, I think until you've fully evaluated, like I really think we need to think about this as a normal selection set. So like the first step is like translate it to a selection set.
Yeah, but that's also what we do. And then we fetch, right?
No, but that's not what you do when you specify these arbitrary rules.
Why not? Because the selection set, that's the outcome is the same.
I think my main misalignment with this is that if this is not a one-off, is there really a choice?
Well, you can have a choice. That's what I mean. Like you can say instead of dimension bar bats there, you can say weight 5. And now you can pass in if dimension is a movie, you can pass in a value for weight. For example, you could have an enum value, and you say that in case of in case of movie, you pass in watchable. In case of whatever, you pass in that, and then you have the default value.
Yeah, but I think that's where the double question mark operator comes in. But that has very different local semantics and very clear semantics.
But it's
not about choices.
But the outcome is not the same because a book could be also a movie, and then you would get the emotional weight from the movie, and you would get the weight from the book, even though what you actually want is you want the emotional weight from the movie. And
I think we need to see specific examples because it keeps, but not like I think we're constructing. We're constructing fictional examples that don't really
Well, I have an example, but I hate it. Because it's bad. It's most likely very bad. But
Yeah.
the thing is that one case where what I see people do, or what I will see people do with this, is that they pass in the type, so that they can in the resolver they know what they extend.
But I don't see
What do
how
you-
that maps to requires. Like I think we're really overcomplicating. Like none of this functionality is currently like part of the federation mapping. And I agree it's useful to be able to do this, but
Can you put in a type name in the requirement in federation?
using the normal like type condition syntax.
Yeah,
Yeah,
it's
Underscore type name, right?
yeah, they have this field set. If I right, and you can just and you write it's a selection set, right? Just
No,
that
I mean
you have
Yeah.
underscore type name is something that you can set there, right?
You can set it, I think, for us, but yeah.
So I mean, what you can do with this is that you can say, can you alias this one quickly? And you can say is movie.
yeah, yeah, I know.
And you can do the same for two different types. And now you know in the resolver if in the requirement if you're dealing with a movie or if you're dealing with a book.
I mean, you know that anyway, right? You can like if you have a one-off, like that's sort of meant, those top level fields are meant as mutually exclusive choices. So that's where you would put this. You don't need another representation. Like I think we already have one-off to deal with these cases.
Yeah, probably.
The
It really feels to me like we're overcomplicating this, and if we can't understand the semantics, I don't think users will either. And in my mind, like still the simplest semantics are, in effect, this is a selection set, but we have a way of mapping this to a selection set. We apply normal evaluation rules. You end up with a result structure, and then we apply our aliases, or like our extended aliases. Let's call them like extractors or something. That maps to, in this case, an input object, and then the normal validation rules apply. So there's a very clear like distinction of responsibilities. Like for instance, and like our language doesn't need to know anything about one-off. Like we can improve maybe like composition errors by statically like analyzing things, but we don't have to specify those rules. It's
no,
just
you are
the normal
you're right.
mapping.
We don't need to have a knowledge in the syntax for that. Like the need we don't need one of semantics
No.
in here. But like I can see this for requirements,
Well,
but here it becomes
a-
very complex from to pick these, right?
we do
You
have
have
an issue
to
with one-off.
Hmm?
We do have an issue with one-off. Even if we use this, if when we do this, we have an issue
Why?
because you need a fallback. You need to
What you have?
no, here you need to fall back to null because
Why?
if
Not
it's
to null, to unspecified, you mean?
no, that's a execution error. If you don't have a movie and you don't have a book, this thing is an empty object.
Yeah.
And
So in that case, like dimension input is null, right? If it's nullable, and if it's not nullable, you get a runtime error.
Yes, but that's now a weird evaluation rule because you specified the object.
No, but that's not an additional evaluation rule. That's just what happens when you like if it had been an object literal, you would get the same type of
No,
validation.
I mean you can have an empty object literal, right?
Well, you can, but if you try to map that to a one-off, I think, well, would have to look it up, but I assume the one-off semantics specify that there always needs to be one and exactly one.
Yeah.
Exactly,
then
yes.
it's exactly one.
There needs to be
Yeah.
exactly one and only
Yeah.
one.
Yeah. So
So
we don't need to specify that. That's just part of how we convert from basically an input object literal to the
no, it's
argument
not.
type.
But what we would come if we just use the normal evaluation that we use from GraphQL, this would be an empty object.
Well, it would be an empty object in the case where it doesn't match movie dimension or book dimension, right?
Yes, that's the empty object is different from the object is null. That's a specific rule that we would have to
Oh,
specify.
no, but we don't need to specify that. We don't need to convert it to null. It's just that when you pass in an empty object to a field that expects a one-off, like the
And
one-off semantics are.
No, you have a runtime error.
Well, yeah. I mean that is a runtime check. Like argument values are checked at runtime,
Yes.
But
and
what is
we can like and I think that's the basis, right? Those we can always in implementations perform sort of static validation, like that's possible. But that is just a way of like the semantics are still the runtime rules, the conversion rules.
But you couldn't specify this here as if
so are you just to get that right, Pascal, you
Yeah.
are worried about this case?
yes.
Which case?
Okay, so what let me so the what Pascal is saying, like let's say this is nullable here, right? Dimension input.
Yeah.
And in this case we would have, let's say, either pick this choice if it's movie dimension, or we pick this choice if it's book dimension. But if it's not one of these, it fallbacks to null.
Yeah.
Because
And-
that we couldn't do with this this syntax, right?
I'm not sure what the expected behavior is when an empty object is mapped to a one-off that's nullable.
That's a runtime error. You
Yeah.
have to set exactly
It would be a
one-
GraphQL validation error if that's the case.
You have to set exactly one value.
Well, it's not a validation error, right? Because
It's
it
a
has to,
validation error.
No, but I mean, it can only be checked at runtime. When
Yes,
it's
it's
Yes,
You
okay,
have-
yeah, you're right.
when-
It's a validation error if it's literal, and it's a variable coercion error if it's
Yeah.
uh,
Yeah, you're
if it's
right.
not.
Yeah.
But it would lead to an error.
And I mean, isn't that expected? Because it is an error.
Yeah, I mean, I'm not
Is-
saying it's not expected. The question is,
is it?
how do you get out of it when you want to say that? Again, like there's a possibility for it. So probably someone at some point in the future will do it, right? So I'm not saying that we have to. It's just that when we try to solve this issue, we would at least need something that works in all of the cases that we can now come up with. Because as soon as we pass this to people to use, then they will come up with cases that we didn't think of, right?
So the way I would solve this is by using this operator there, right?
But it's really strange because it's not null, right? It is an object. It is a thing. Like if you evaluate this to an empty object, then you have the double question mark behind it. You expected the double question mark to never be that shouldn't never be hit because it's an object.
I think it depends on the semantics that we define for the double question mark operator. Because it's already in many languages more than just like is something null. Like it also triggers on like undefined, for instance, if a language has a concept like
Yes,
that.
but in this case we are not undefined, right? This isn't like this would produce if it's not a one-off. Like if we leave this one-off away, like it would just produce an empty object.
Yeah. It seems like a very like I'm not sure
it's all
that that's
it's all edge cases, right?
yeah.
Like for most cases, I'm for most cases, like people have probably very simple choices, but we should go through.
Yeah. I mean,
the
my
issues.
problem, I still don't see how we can make the choice operator work. I think that's part of the problem. I don't see why we need it. That's one issue. But I also don't see how we can make it work reliably because every time I've heard explanations, they seem to start out from the idea that you sort of you really have to specify your own evaluation rules. Like you would basically say, instead of saying that a type condition that doesn't match just skips the fields, now you somehow have to like go back to the most outer choice operator and say that we skip the whole like left-hand side. Um, and it's easy to explain when it's just a single field, but if you have multiple fields and you have subselections and you have overlapping type conditions, it's not as simple.
Hmm.
Yeah, but isn't that exactly what um, programming languages do when you have pattern matching?
Well, sort of, but that's one of the most complicated parts usually. If this, I don't think we want to specify like additional pattern matching semantics over what GraphQL already gives you. So that's why I'm really hoping we can have clear boundaries, clear responsibilities between the different parts of the system, and like the semantics we specify for our language are basically a translation to normal GraphQL selection set syntax and a way of evaluating that.
Yeah, I mean, I don't think, Manhan, that we are not doing that, right? In both cases, I would say this is based like this translatable always to a selection set. But
not with the choice operator.
But I don't see.
it's still it would still I know maybe where you don't like that, but in essence you can translate that.
No.
When
You can specify expressions using the choice operator that you can't actually translate to a single selection set.
How?
Because the expectation is that look, even this
Even
one,
this.
because
I mean, this.
here movie dimension and book dimension are object types, right? But if it's if these are abstract types and potentially overlapping types, the semantics of a selection set with two type conditions is different from the intended semantics of the choice operator here. Because with a normal type condition, you always evaluate all type conditions. And here, the semantics Pascal were suggesting would basically say, as soon as one type condition doesn't match, that whole like left-hand side of the choice operator gets discarded, and you immediately move on to the next one.
But that is already after the selection set. I'm just okay. Where I'm coming from here, it's just all of these syntaxes can be translate into the same selection set.
No, but they can't be.
Yes, they can, because like this would just from a what we fetch, right? I think where the difference is what we do with the data we fetch after we fetched it.
Yeah, but there's just to go ahead. Go ahead.
Right? Because it would translate to this in both cases. This would translate to this, and this would translate to the same thing. And that would be basically fetched from there. What Pascal suggested is when we validate this object, we look at I don't know what you inject. You probably need to inject in this case a type name, right? And then you validate based on that what data you keep and construct the input side from. But we do that also for this, right?
Yeah, you need
We-
the type name unit anyway.
Yeah, I mean, you're evaluating against a concrete object.
Yes,
yeah.
I think yeah. Yes, I get your point why this is more complex. Because here you really need this, right? In this, it's just taking the data and maybe doing a bit of massaging to get it into the shape. But in essence, we would end up with either this is already produced or it is not yet produced. That's your point, right? Yeah, because in your suggestion, and I'll take the simple case, like if we have this, right?
Yeah.
Then if this doesn't is not true, this value is not produced.
Yeah.
There's also no null. It's just not produced. And if this is not true, this value is not produced. So there's actually no pre-processing, except if we have like these guys, right? Then there is.
Well, no, but let's leave those out for now, because even if you don't have those, like as soon as you change type condition to an abstract type, for instance, like there could be overlap. So you immediately get into a situation where you can also have both emotional weight and weight. And it gets even more complicated when you have like the same field under multiple conditions. And that field could be a composite field, in which case the normal GraphQL selection set merging rules apply. So you're basically performing this recursively. And you get into really complex, like if you don't follow the normal GraphQL selection rules, but try to apply additional semantics on top yourself, I really don't see how we can make that understandable.
It's I like there's a base choice we have to do, like in any case here, like this has basically no post-processing.
Yes.
It's just if like without any question marks
Mm-hmm.
and without anything, right? There's no post-processing needed, except from pulling these up, right? But it's cheap.
And if they're not there, it's actually not even pulling them up. It's actually just it's the object.
Yeah, we take what we find on the transport and we put it in.
Yes.
And this is it's the same selection set that we produce, the same result we get, but now we have post-processing where we make choices how the object that we inject really look like.
But if the choice operator only applies in the post-processing phase, I think you get really confusing semantics, because you're basically merging, you are merging these individual choices beforehand, translate it into a selection set, apply like normal type condition and selection set merging. And then there's a post-processing step where you do consider like the left-hand side and the right-hand side as sort of separate constructs.
Yeah, I think that's
that gets even more complicated.
I think that's where we conceptually are not on the same page. It's that in the end there's only one selection set. This selection set is translated to a JSON, and this JSON then is somehow put into this input object. These are the three steps in all of the examples or that's at least how I have it in mind, in all of the examples that we have here. First step is generate the selection set. Doesn't matter if you use choice or the other one, just generate the selection set. Execute the selection. You receive a JSON file, a JSON object, and this JSON object you then put into the input of this expected delivery.
Yeah.
And the only thing that would change is in all of the different semantics that we've just discussed, the post-processing. That's the only thing that changes. The selection set is essentially the same, except maybe the type name.
But
No,
that's what I'm saying. It gets really like if you sort of spread out your single selection set with that choice operator, and again, we're looking at very simple examples here where there's just a single field in each option. But there can be multiple fields in there. There can be sub-selections in there. Those can have their own type conditions. So you get like two sort of complex selection sets. Then we somehow have to merge them into one.
This is also what we have to keep in mind. It's only if you need these choices only if there's a one-off.
Yeah, and that's what I find even less compelling to special case one-off in the mapping syntax, because to me, that's just an implementation detail of the argument type you're trying to map to.
Yeah, but in like whatever way we go, we need like one-off is a special case. How you construct an object.
Well, yeah, but what I'm saying is we don't need special handling for one-off in our language. Like that's just like if you see our language as basically constructing the equivalent of an object literal or of a literal in general, then the conversion from that literal to the type of the argument is a completely separate stage, and we already have rules for that in the GraphQL spec, including special casing one-off. But the first stage doesn't need to know anything about one-off or even what type it's mapping to at all.
I mean, the first stage, I think here, this is in all cases the same. That's important to understand. We fetch always the same selection set, no matter how many choices you have. It's one selection set that this represents. But
it isn't even clear how we can validate that reliably and give feedback to users, because if the choice operator offers you sort of an additional level of merging, basically, like these are two potentially very complex selection sets that get merged together because there is a choice operator. If you apply normal GraphQL validation to the result to that merged single selection set, it isn't like it's fairly complex to map that back to the syntax that the user has written. It's a huge level of interaction.
And we would have to see a more complex example, I think, for that.
I will write down a few examples, and I will put the examples into both syntaxes.
Yeah, but what I like, what the fundamental choice is. So let's not struggle about syntax, right? Is do we need in this case special like all the question marks or whatever? This is like a kind of a choice to influence how we construct an object from the data and a way to discard data.
Yeah.
That is still what we want. Otherwise, one-off gets really difficult with this.
Yeah, but especially one-off is not solved with this. Without the
No, I'm not saying that I didn't want to make a decision here on question marks or whatever. I just wanted to get the basically we do want some kind of choice logic, right?
Well, I mean, there's a question like, what do we mean by choice logic, right? So the double question mark operator is a local operator. It's just giving you a value.
Yes, but I agree on that, Martin. It's I'm not arguing on do we do this or that, but we want some kind of mechanism for that to see it abstract. If it's local or global, I don't
Yeah,
mind.
yeah. No, but what I'm saying, it's a very different notion of choice, because the bar suggests like much more complicated semantics. Like you're not just choosing between two values, you're actually trying to choose between different options for constructing in a one-off.
That's correct.
Yeah.
And when you have like object with multiple fields, et cetera, it isn't clear what that choice actually does. Because in the case of a double question mark, it's clear. It's like if it's null or undefined, potentially an empty object, that's when the fallback applies. But in the case of a bar, like there is no direct choice there. Like it's only a choice because we specify additional evaluation rules.
Yes, I get why you oppose this. So I mean, I ran into that while implementing this, that it's not very clear what this means, and either we have to specify semantics around that, or it will not be clear what the choice is. And I'm not saying that we have to do either one, but it's more okay. We need some thought of mechanism.
Yeah.
Otherwise, we cannot have one of, at least for requirements.
I would say for the next time, let's try to start from some concrete use cases, some concrete examples, and work those.
Like what we did with the selection map syntax in the first place, right?
Yeah.
Yeah. Maybe can everyone that will attend next week look for use cases? We can, but that we get a couple of examples that we can work from. Also, like Martin, you guys might also have very complex ones, so which are not that we also get the edge cases where we see where it falls then really apart.
You mean based on like the current requires usage in Federation?
Yeah, it could be just that you say, okay, this is the case that we have in Federation today.
I mean, we don't really support complex semantics. Like we don't have like one-off support. We don't have like fallback syntax. It's basically just a more limited selection set.
Yeah, but that we get a concrete use case of a selection set with fragments and stuff like that. So so that we get into where people want to make a logical choice, because the choice I bet people are doing these choices also in Federation, just that they get the data pumped from the gateway into this into the subgraph, and then they make the choice in some cases programmatically, right?
Well, yeah, and I think that's an important distinction here. Like with the current Federation architecture, like it's basically untyped, right? There's no mapping to an input object
Exactly.
type. So we have
Exactly.
Yeah. All right. I think that was that was the whole meeting again.
Yeah, but it's
Yeah.
important. Like we have a rough idea of what we want, but there are differences in how you can approach this a solution for this. So let's get it right.
Yeah.
And then see you next week.
All right. See you next week.
Bye. See you.
See you, Steven.